9.2 Pythagorean Theorem problems. So the first question is, what is the slant height of the square pyramid? So what we look for in these is we're looking for that right triangle, and I can kind of see how they drew that right triangle in, and we can see that there's another right triangle here in the other corner, but we don't need to know that one right now. That would be a different Pythagorean theorem. So we would need to find this side length. So a lot of times what I like to do is redraw, and it really helps me kind of put the things that I need in my drawing and take out all the other extra stuff. And remember, this dashed line back here is that kind of back edge that we can't see, but it kind of gives the illusion that it's a three-dimensional figure. So we have this right triangle, and I notice that this arrow right here points to I would call the base of that triangle, so 4.8 inches. And over here, this 6.4 is this height here, so 6.4 inches, and that's that height. Oh, and I have my hypotenuse over here, and that is the C of our right triangle. So what I've done now is I kind of get my mind in the right places. So I'm going to label this one A and this one B because we are going to use the formula a squared plus b squared equals c squared. And we want to write that down. It's formula, then substitute. So 6.4 squared plus 4.8 squared equals c squared. And bring everything else down. It's really important to bring all this stuff down for solving our equations. So what we'll do in our calculator now, or we could do a little sideline math over here, but typically this is on the calculator section of tests, unless they're easier numbers, but these aren't that easy of numbers. So we'll multiply 6.4 times 6.4 is 40.93, and 4.8 times 4.8 is 23.04. Bring down my c squared, so it's solving an equation, so I'm just continuing to do that. And I'll add those together to get 63.97 equals c squared. And now what I'm going to do is continue solving my equation, and to cancel out that squared, I'm going to take the square root. If I take the square root of one side, I need to take the square root of the other. And this definitely would be on a calculator section of a test. So we'll bring down the c and we'll take the square root of that answer, which will be 7.9981247.8. And I know that this is going to be not exact because the calculator does round it to all those decimal places. So what I like to do is I do like to write down all of the decimals there for the first one. I'm just copying them down, and now I'm going to round them. And since my place values here were two place values, I'm going to round to the hundredths place, which means the 8 tells me that I'm going to have to take that 9 and round it up from 9 to 10, and then that gets carried. 9 plus 1 is 10, and that gets regrouped to 7 and 8. So now remember, we rounded it, so we need our approximate C. And then I do need a label, and our label, I look back up here, is inches. That's my last thing, inches. Now, a lot of people will write 8 inches as their answer, and technically that is incorrect for this problem. If it had calculated out to be an exact 64, and we took that square root of both sides, c squared, and canceled it out, the square root of 64 would be 8, and we would be correct on that one. But that is not the case here. Hold on, I'm going to get rid of that so we don't think about that. So that is not the case. So 8 inches is not, but it does round to 8. So to show that it was rounding, we want to show those two zeros. We do need to have those in our answer. because of the rounding here, because it's not exactly 8, it's 7.998, and that is close to 8, but not exactly 8. Now, if we have a different problem, and this one says find the perimeter. So perimeter means around the outside. So here we have to be careful because in earlier your mathematics would be that we would find the area or the perimeter of the rectangle, and then another problem, a different problem, we'd find the area of the triangle, but we're putting them together. So the perimeter around the outside, notice how I'm using a different color, and it goes all the way around the outside, which is the perimeter, but we don't include this middle for the perimeter. So notice how I'm going to make that into a red that matches that color of the perimeter. So now I need to figure out this x side, because I do know that this one over here is 5, and this one over here is 5, and this one's 13, but I need to figure out what that x one is. So to do that, I notice, well, it is a square, so this square also has a square over on this side, a right angle on the other side, so that makes my right triangle. So I do know that this side length over here is a 5. Hey, that's my Pythagorean theorem. So I'll write that formula down. A squared plus b squared equals c squared. And do my substitution. 5 squared plus, wait a minute. That 13 doesn't go there because I feel like I want to put it there, but this 13 is my C, the longest side. So that means my X is my B. So that means my X is going to be substituted in the B spot. So I'm going to square that X, bring down the equals, and my C is 13 over here. So you notice how that can be that's the tricky part about this one, because we're thinking about all these other things that are part of that problem, and we need to get those numbers in the right place. So once we have that, we can do our solving. So 25 plus x squared equals 13 times 13 is 169. And then to get x by itself, I'll solve it, continue on solving. Those zero out and bring down my x squared equals 4 and 1. So I remember that number. That popped up before. If I'm going to cancel out that squared, I need to take the square root of it to cancel it out. And if I take the square root of one side, I take the square root of the other side. And x, you bring down my x, equals the square root of 144 is 12. So that means that 12, that's not my answer, that 12 goes right here for my perimeter. So that means I'm going to have 3 5s, which is 15, plus 12 plus 13. So that, and remember, we don't count the middle 5 here. That was just to help us find the Pythagorean theorem, the side length of one of the legs, but we don't use it in our perimeter because now we're looking at the red perimeter. So 5 and 5 is 10, regroup. So 40 is our perimeter. So I'll write P, perimeter, capital P, for perimeter is 40 centimeters, because that's what our label is right here, and here is centimeters. And now I'll circle. So this is a very 8th grade problem where you had to do the Pythagorean theorem, but not just end right there. You had to do a little bit more, and that little bit more is not a whole lot, a little bit more. It's like just a little bit of adding, but we have to make sure we get the thinking of the right numbers that we use. So our perimeter is 40 centimeters. Now, the way that they can make this one a little bit more complicated is changing your scale. So instead of both centimeters, they could put one in meters and centimeters, and then you have to just change one of them to centimeters, or all centimeters, and then you can go and do your solving. But we won't do that in this problem because we're just going to be using the same labels at this point. That'll be for later on in your more complicated mathematics.